I'm Jonathan Frankel. I'm Chief AI Scientist here at Databricks, and I'm one of the leads of our AI research team. I came in through the MosaicML acquisition where I was one of the co-founders.
Hi, everyone. I'm Pallavi Kapul. I'm a research scientist here at Databricks on the RL team. I'm super happy to get to chat with you all today. And Jonathan, do you have the clicker? Because I don't.
Oh, I should grab the clicker. Clicker would help. So we're going to talk to you today about evaluating your AI systems from first principles. It seems like this is a rather popular topic, judging by the size of the crowd. And all I will say is it should be a popular topic. And I'm very, very glad that there are this many people who recognize how important it is, how hard it is, and kind of honestly how much of a mess it is right now. I'm just curious, as we let people trickle in, how many folks here have an eval for an AI task right now? Raise your hand if you have an eval. OK, we got a good crowd. Keep your hands up. Keep your hands up. We're not done yet. Keep your hand up if you are proud of your eval. And there go most of the hand. I see some heads shaking. I'm curious, as we let a couple people trickle in, if somebody whose hand went down can just kind of tell me, like, why aren't you proud of it? What are you worried about? If somebody wants to be brave and raise their hand, like, what scares you about your eval? Anybody? I saw a lot of hands go down. There we go. Go for it. OK, so let me repeat that one so everybody can hear it. This is actually one of our friends who we've been working with to build evals. And they're going through the process you're going to hear about today. And one interesting thing that happens is, we need LLM judges that can do evaluation, at least for open-ended tasks. So there are many ways to do a right answer. You'll hear about all this in depth in a few minutes. It turns out that when you try to get humans to perform evaluation for your task, let's ignore the LLM part, just get some humans to sit down and do it. Turns out the humans don't always agree either. And if you have a task where the humans can't agree, then you might want to revisit your task definition, because if reasonable humans can't agree, it's tricky. OK, it looks like we're closing the doors, so I think it's time to get started. That's a great setup. So just to give you a little bit of motivation here, I'm going to give you a bit of a metaphor. So suppose you're building a new software product. Let's ignore AI for a moment. We'll worry about AI in a few minutes. How many people here have written code before? Yeah, OK, yeah, I mean, come on. If you're coming to this talk, you've probably written some code before, I would guess, for most of you. How many people have shipped software before, like actually shipped code that has gone into production? Yeah, I mean, it's pretty common practice for folks who are doing AI. Let's say you write it. So this is how software engineering works in industry, in my understanding. You write a 1,000-line script in Python. You might vibe code it, but you write it somehow, just 1,000 lines. You don't need functions. Just write it straight through. You play with it a little bit. Just check it out, run it on a few inputs, make sure it works. Seems good. And then, you ship to prod. That's how software engineering works, right? Yeah, this is, speaking as a former professional software engineer, you were a software engineer for a while.
I was a professional software engineer.
This is how you ship software to, self-driving cars, right?
Definitely not.
They're very safe.
They're very safe.
Yeah, no way in hell would anybody ever ship a piece of software this way. You would be insane. That would be crazy. Now I'm going to replace the word software with AI. Or, this is how you actually do software, first of all. You write a design doc. You break it into modules with abstraction boundaries. You write unit tests for typical cases and corner cases. You write some integration tests. Then you actually build the thing, and you know it works before you ship it. That's how you do software engineering, right? Or at least closer to it. OK, now I'm going to give you the exact same thing I gave you on the last slide for how you build a piece of software. I'm going to just replace everything with AI. And now this is how people build AI today. If I said software, you would say I'm crazy. If I said AI, you would say, yeah, sounds good. Let's go do it. I was chatting with one of our friends, one of our customers recently, and they said something that is not atypical, so I'm not going to call them out by name. We haven't upgraded from Claude 3.5 to Claude 3.7 yet because our person who does the vibes is on vacation. How many people here does this resonate with? This sounds like, the person who's doing the vibes is on vacation, so we can't upgrade to the new model. This is something I actually hear about a lot with AI systems, like, check the vibes, seems good, doesn't seem good. Oh, we've got that one person on our team, we've got Carl, and Carl has really good vibes. And seems to really know. I have someone on our team, his name is Sam. He has really good vibes. That is true. This is the reality today of building AI, and I'd like to hope there's something better in the world. The contention I'll make for you, I know everybody has said 2025 is the year of agents. Genuinely, I don't know what that means, but we call everything agents now because 2025 is the year of agents. Last year it was it was LLMs. The year before that, it was GenAI. The year before that, it was AI or AGI. But the year of agents. I want 2025, this is something I'm trying to manifest for everyone. 2025 is the year of AI engineering. What I mean by that, this is the year we move from AI demos and vibes, if I want to be derogatory about it, to AI engineering. What that means is, the watchword is going to be reliability for everyone. Reliability is something we just take for granted when it comes to software. But I want it to be the watchword for AI as well. I want you to deploy a system that you believe will actually work. You have some confidence about it. The question I want to ask to people, this seems like such a trivial question. Imagine, again, I swapped in the word software. I want you to build a piece of software that will still exist in a year. Well, of course. That's how code works. It's like, I want you to build a building that will still be standing in a year. Of course. That's how we build buildings. That's how we do civil engineering. I want to build an AI system that will still exist in a year. How many people have built one of those with GenAI? Okay, we got a couple hands in the back there, the people who are hiding. Okay, one hand up here. Yeah, it's tricky. I would like to get there. How do you build an AI system that more than one person can work on simultaneously, where if two people make a change at the same time, they don't completely break each other's work? Imagine trying to do that to a prompt right now. Good luck with that. In software, imagine if we couldn't have more than one person work on a piece of software at the same time. Good luck building anything of note. On a building, two people working on the design at the same time. It is crazy where we are in AI. That is the thing I want to convey right now. It is insane that we have accepted this as a way of operating. How do you build a million-line equivalent of an AI system? Which is probably a lot of pieces of software that a lot of folks are running today or have contributed to at some point in their careers. How the hell do you do that with AI? That's what I want to get at. Our belief at Databricks is that it all starts with evals. We want to be eval-driven in how we do things. And you actually saw that yesterday if you came to the keynote and you saw Ali present our Agent Bricks product. That Agent Bricks product, if you saw the demo, this was the energy drink demo. That's the most memorable way to refer to it. The first thing that Casey did when she got on stage, she's the PM we work with on all this stuff. The first thing she did when she got on stage was not, let me build an agent, let me build a prompt. It was, let me build an eval. It is baked into our product from the start. If I can give you one differentiator for doing AI at Databricks with our products, it is that we are being completely eval first and reliability first in how we're trying to build this. Because I'd like your AI systems to have all those nice properties. I'd like them to exist in a year. I'd like them to be things where they don't keep you up at night and you're not afraid of that they offered all your customers free stuff while you were asleep. I want you to not, I want two people to be able to work on this at the same time without stepping on each other's toes. That is the future of what I want things to look like for AI, and it's going to have to start with evals. So with that, I'm going to hand it over to Pallavi because she has the actual technical details. I have the opinions. We'll proceed from there.
So before I get into the outline, I just want to say that there's a lot of, when we talk about the word evaluation, it's actually quite overloaded, right? Probably what I'm thinking I want to evaluate might be different than what someone else is trying to evaluate. I'm going to narrow in on talking about evaluations as a way to systematically measure quality. The reason I talk about quality is because we talk to a lot of customers, and a lot of people's bottleneck is I don't know if the quality of my system is high enough for me to put it out in front of a wider audience. And this word quality comes up a lot. So I'm going to start talking about it in that way through the remainder of the talk. So first, we'll kind of talk about the challenge, like why is measuring quality important? Hopefully many of you already think it is, but for those who may still not believe, we'll just dig a little bit into it. And also what makes it so challenging. Then we'll take a step back and talk a little bit about a framework we use here at Databricks that we kind of refer to as a 3x3 approach for understanding what your evaluation needs are based on where you are in the GenAI lifecycle. Then we'll give a little bit of our solution for a recipe for building a gold standard evaluation, particularly an offline evaluation using LLM Judges. If you have like a verifiable task or stuff, this is a lot easier suddenly, right? You're like, well, does it work or not? But when it's fuzzy, it gets a little messy. So that's what we'll focus on. And then we'll wrap up with some takeaways, discussions, next steps, and some tools here at Databricks that can help support you through this process. All right. So the challenge, why bother measuring? I guess I'm kind of giving it away here, but measuring and improving quality.
And you're preaching to the choir. These are
they're
300 people who came out to hear about evals.
It's true. So we'll kind of get through this one quickly, I hope, right? So the main reason is to enable performance improvements, right? You want your application to be better. What does better even mean? How do you target areas of improvement in a strategic way, right? How do you know that changes that you're making are actually improving and that you're moving in the direction that you want to move in? Something I often talk about when it comes to evaluations, just as an aside, or applications in general, is things are often like a vector, right, where there's a magnitude and a direction, and people tend to care a lot about the magnitude and improving performance. But making sure that that directionality is correct, super important and super overlooked. And that's what I think having a robust evaluation and a clear definition of quality can really help with. So yeah, make sure that the work you're doing is actually moving you to where you want to go. In the spirit of that, right, a lot of us want to build applications that we can scale confidently. We want to know that as we increase the volume of traffic that we're getting, that we're having reliable quality over all those interactions. We want to know that we can, that we can evaluate large volumes of inputs and outputs in a robust way, right? Not just have our one very tired SME or subject matter expert spot checking things. And then also, why is any of this useful? You want to grow user trust and adoption, right? You want to give people consistent experiences. You don't want it to be they show up once and it's great, they show up the other time and it wastes an hour of their day. And that way you can kind of prevent quality-related user churn. It's really hard to win back that kind of trust in an application. So that's great and all. So now we believe that measuring quality is important, but what is it that actually makes a solution good, right? That's still quite unclear. There's many use cases. There's customer service automation. I don't remember which examples I put up here because there's so many: code generation and review, summarization, content creation, question answering, document analysis. There's so many things. GenAI is so flexible. There's so much we could do with it, and that's amazing. But also it means that all of these different things have different quality requirements. What makes a code generation task really good, probably different than what makes a question answering system really good. And even within a single category, right? What makes a medical question answering system good is going to be different than what makes a legal or a technical question answering system good. And the central issue here is that everything is so subjective and so context dependent that it's hard to have a one-size-fits-all solution for how to improve quality or what quality even is. So that's kind of a non-answer to what makes a solution good. But what we can focus on is what is the measurement gap and how do we bridge that gap, right? If we look at what we need versus what we have, what we need are kind of reliable quality metrics or signals that we believe in. Things that scale as our solutions scale, and that are consistent and that we believe in repeatedly. What we have, kind of as we discussed at the beginning of this talk, are manual spot checks, just randomly sampling and being okay, well, these looked good enough, I guess. Some subject matter experts, like the vibes guy, who is just this is good enough, I believe in this, and you're well, I believe in that person, so okay, we're good. And just vibes all over the place. So how do we actually bridge these two things? A lot of us are using LLM judges, right? And so we also think LLM judges are great if they're well calibrated, right? So in an ideal world, you could take those SMEs who have that really good sense of taste, I would say, for what is quality, and then encode that into something that scales more than any person individually could. Great. So that's, okay, well, more detail on why calibrated LLM judges are.
Yeah, and sorry, I threw this slide in there.
And my vision's not very good.
Yeah. So. Sorry, I threw in a bunch of slides at the last minute just to make Pallavi's life very fun. But why do you even use calibrated LLM judges in the first place? Why aren't we using multiple choice questions? Why aren't we, MMLU style? There are a lot of different ways to do this. Why aren't we using verified answers of some kind? And I think for most of the tasks I see in reality, they don't look like Math Olympiad, and they don't look like multiple choice. They're open-ended. There are lots of ways to say the right thing. You care about what is said and how it is said, not just that the right answer was somewhere in there. And there are a lot of ways for an LLM to say the right thing. Fuzzy behavior of LLMs requires fuzzy verification. It's subjective at the end of the day. And our belief is that LLMs can emulate human judgment if only they're calibrated carefully. And that's the most important part here.
All right, so now that hopefully you all believe, as we do, in calibrated LLM judges, it's great to have a judge and all, but there's a thing that we haven't really talked about, which is what are those judges going to be judging, right? Like, what are the inputs that those are actually going to look at? So let's talk about that a little bit briefly before we get into how to actually calibrate an LLM judge. So like I said, we have a 3x3 approach, and the first thing it starts with is this idea of what I call must-haves. These are the things that your application is kind of uniquely trying to solve. If you're kind of setting up an initial proof of concept, this is where you're like, thank you. If you're trying to set up initial proof of concept, this is when you're like once you get this right, that's when you start to say, we have signs of life here, it seems to be working. Until you get these things correct, you're like, I'm not sure, right? And then there's the must-not-haves. I think we probably all have a general sense of what the must-not-haves are for our particular applications. They're often, but not always, informed by legal and regulatory requirements. These are just inputs that we want to be a little careful around. We want to make sure we answer them in reasonable ways. It doesn't have to be anything as dire as don't insult my customer or whatever, though it could be. But it could also be like, hey, we don't want to talk about this particular set of topics. All right. And so you can think about these two things as defining the expected usage of your application. Another kind of way that I like to think about evaluations, and that I encourage everyone to think about them, is as a product specification. I think in a software development lifecycle, we sometimes think about evaluations and tests as just checking to make sure it works as expected. I think in the GenAI world, it's very helpful to have a much more proactive stance and say, this is defining how this application should behave and the parameters of that behavior. So that's all well and good, but you might be thinking, where's the third thing? And the third thing, unfortunately, is actual usage, which is what customers actually do or users actually do, not always correlated with what we would hope they would do and what we would like for them to do. So great, so we have these three ways to kind of slice the set of questions or the set of inputs that we might care about in our evaluation. But I want to note that evaluations, and this is something that will keep coming up, right, are evolving, they're not static, and they will also change based on where you are in the GenAI lifecycle. So we like to split this into 3 stages, the proof of concept or 0 to 1 stage. I'm actually very pro vibes here, and just being like, all right, does it work? Is there any signal here? Is there any promise here? And then there's the pilot, or the 1 to n-1 kind of phase, where you're like, all right, I think it works, but can I get the quality to be consistent enough and high enough that people can actually use this in a meaningful way at scale? And then finally, there's a production phase, right, n-1 to n, which is, okay, I believe it can operate at scale. Let's see how it actually does, and start monitoring, look into things relating to observability and things like that. So if you put this together, you get this kind of grid. I'm not going to go into it in a lot of detail, but the main thing I want y'all to take away from this is that in the proof of concept stage, it's actually okay to not care too much about actual usage and just kind of see if there's any signal based on your must-haves and must-not-haves. And then you want to get to the pilot stage, where you get kind of more comprehensive coverage, start to get actual usage, all of those things. What we see in practice is that this pilot stage is what I call the Bermuda Triangle of GenAI, which is a lot of people can get there and a much smaller proportion can get out to production. And the main reason for this is because everyone if you recall, right, the main purpose of the pilot stage is to improve quality. But again, if your directionality is not correct, if you haven't correctly scoped what metrics you're improving, it's really hard to get to a place where you feel comfortable moving to production phase. So our whole belief here at Databricks is just how do you move through these as quickly as possible, recognizing that this is part science, part art, and quite empirical. All right, so let's talk now about a typical recipe for building a gold standard offline evaluation set with an LLM judge and how to calibrate that judge. I'm going to talk about it at a little bit of a high level, so those of you who have already implemented a judge, this might be familiar to you, but I'll throw in some like quick tips and tricks along the way. And you can also feel free to ask me any questions afterwards. All right, so first things first, what you need to have is some sort of proof of concept running that can log inputs and outputs, right? Some basic measurement system set up there, and some notion of your target audience. And again, I really encourage you all to think of an evaluation as a product specification, especially at this stage. Like, what are you trying to do? Like, what are you trying to shape here? Who's going to use it? How is the system supposed to help them? And you can refer to those must-haves and must-not-haves exercise as a way to kind of get off the ground here. And this is just to give an initial structure to your evaluation, right? Like eventually we'll refine it more with the help of actual inputs. But for now, you're just kind of getting something off the ground so you can see if you're in the right ballpark at all. Then what you're gonna do is, depending on your comfort level, collect inputs from either a pilot target audience set, so like a small set of actual users, or you can use annotators acting as your target audience, right? You can basically brief them and be like, hey, take some employees at your company, be like, here's who our target audience is, can you ask questions or interact with the system as if you were a target audience member? One thing that I want to note here is we always encourage that an evaluation benchmark be on the order of at least hundreds of samples. And I know that seems like a lot when it's hard to get any data from anybody. But the reason for this is because the more samples you have, the lower the variance in your measurements and the more coverage you have, right? So what I mean by this is, if you only have 2 examples, you're probably missing a lot of possible interactions users might be having with your system. If you only have 1 example of each type of interaction a user might have with your system, you might be overlooking some nuances like, oh, maybe someone uses a different way of describing something or like shorthand for something, and actually my system doesn't cover that. So you kind of want to get good coverage here. In practice, it's sufficient to start with even 50 high quality samples. Again, we are really interested in helping people move through this process as quickly as possible and not letting perfection be the enemy of the good, so to speak, right? Because you just want to make sure that you're traveling in the right direction. And as soon as you start doing so, you can kind of start collecting more inputs that will help facilitate that even more easily. Right, so this is just all to get you off the ground. So then what you're going to do is you're going to define specific annotation guidelines. What I mean by annotation guidelines is you're going to sit down and be like, what are the 3 to 5 things, the 3 to 5 axes that I care the most about, and how do I specify those as precisely as possible? And this will differ from application to application, right? But in a generic case, right, someone's might be, you might want to ask, does the response that this application gave, is it relevant given the user input and any additional context provided to the model at the time of that input, right? And you want to be really precise about this. You can use a Likert scale, binary responses, just like any sort of categorical response here, it's all fine. You just have to be specific.
Yeah, to give you a couple other examples that I've seen in the field, things like medical accuracy being one category, helpfulness being another category, not giving medical advice being another category, because this is, there are a lot of tricky medical situations where you want to be medically accurate, but not give medical advice, because then you might get classified as a medical device. You might want to have conciseness as a category, depending on the nature of the response or kind of how conversational it is. It might be brand guidelines and making sure that it's in accordance with the tone that you want to set or the voice you want to set, or that it talks about your brand properly. Around Databricks, it might be don't talk about Snowflake, those sorts of things. So those are all really important criteria that you can measure on either yes or no or on a scale of 1 to 7. And don't boil the ocean. Don't decide to do 50 of those categories, or you're going to make your subject matter experts' lives miserable. But again, as Pallavi recommended, 3 to 5 of your kind of top priorities, your kind of biggest categories are the most important ones to go after.
Yeah. And again, you can always build from there. I think just getting into the mindset that evaluations are constantly evolving and building them as an iterative process, because it is, again, that product specification, and that's going to keep changing as your needs keep changing. I think that's a helpful framing as we think about GenAI evaluations. Also, something to highlight is one of the reasons we encourage being as specific as possible is because the number one priority is minimizing the amount of noise in the annotations we get. The noisier the annotations, the harder it's going to be for you to meaningfully improve, like meaningfully calibrate a judge, improve against it, et cetera. You really want to like distill out, this is a super overloaded word now, I guess, but like alignment between your annotators.
Not that kind of
Not
alignment.
that kind of alignment, just agreement, yeah. And so the clearer the guidelines you present to your annotators, the less noisy they're going to be. And ideally, another way to deal with this is to have multiple subject matter experts, right? Ideally 3 or more is typical in like a research setting. I know sometimes we might not have that many folks, so you can do this process with fewer. You just have to be aware that like then you're really fitting to that individual person, and there might be some bias inherent there. So there's a bunch of ways to compute agreement. There's Krippendorff's alpha is a common statistical measure. It basically just measures agreement adjusted for chance, right? So people might agree accidentally, or like, what is it that they say? Like a broken clock is right twice a day or whatever. So these kind of try to adjust for that and see like, okay, how much like real agreement is there? Someone in the audience earlier had said that getting agreement is between like SMEs is challenging, and that is definitely true, and I'm happy to chat more about that. I'll just say maybe 1 or 2 things, but also happy to chat more about that later if that's of interest to more people as well. Typically, there's like 2 levers I think about when it comes to agreement, right? One is the clarity of the guidelines that we have, and the second is kind of like more of an interpersonal, how to get the SMEs to interpret or agree on what the results should be. In general, I think most disagreements that we have encountered are resolvable by revisiting the guidelines and the interpretation of the guidelines and making sure that everyone's interpretation is actually the same. But then there's also like, I mean, this sounds very simple, but actually works super well in practice, which is if you can just get your annotators in a room together and be like, you're not leaving until you come to a consensus on this. Actually, it works really well.
And don't give them food.
I wouldn't recommend that.
I want to give extra emphasis to one thing that Pallavi said, which is if you really can't get your annotators to agree, and it's driven by the fact that your rubric or your guidelines are not precise enough, that means you may not even understand what you're trying to do precisely enough. If reasonable humans cannot agree on whether an output is good or bad, that may mean reasonable humans don't even agree on what you're trying to do in the first place. And this is often a signal to you as the person designing the system that you may need to revisit what problem you're trying to solve and how precisely you've specified that. In designing an actual system for code, at the end of the day, you figure out whether the system is designed precisely enough when people start working on code, and if the code, they disagree at the code review stage, that tells you that perhaps they didn't agree and there's something that forces you to come to an agreement. In GenAI, there's nothing like that. You can go through the entire life cycle of the product and have the 2 people who built the system actually disagree with each other about what the system is supposed to do and not know it. This is a way to find out whether people disagree, and this is a way to get precise in a way that won't happen naturally in GenAI. We take it for granted in code. You can't take it for granted here.
So the final step of this, super final easy step, is take all those subject matter ratings, turn them into an oracle rating. If you only have 1 subject matter expert, congratulations to them, they are the oracle. But for the rest of us, right, collapse them into some sort of singular rating that you're going to treat as a ground truth. And then it's kind of time for some prompt engineering and figuring out how you can get an LLM judge to be calibrated with that oracle rating. So again, this calibration can be computed via either Kripp's alpha or Cohen's kappa. Kind of just depends on like what type of data you're using and how many papers you want to be able to point towards to be like, hey, look, we have a really principled calibration here. And for prompt engineering, right, usually you want to think about the instructions and the few-shot examples. I like to just break this down into thinking about instructions are all the explicit information you can codify into the prompt, and the few-shot examples are all that latent information where you're like, I don't really know how to explicitly tell you this, but take a look at these examples and figure it out yourself. You're like a billions of parameters model, you can do it. And this is, again, an iterative process, and it might take time, right? And something else I want to say is that In a few slides ago, right, we talked about how ideally you want to get to hundreds of samples and 50 is a great starting point, et cetera, et cetera. In practice, and especially if you haven't done this before, like collect data in small batches, even 10 samples at a time. This can be, especially depending on the task, like different tasks take different amounts of time to annotate. It can be a laborious process. I know like SME time can be limited. It's not like this is the only thing anyone is working on, right? Doing small batch collection will help you see progress more quickly. You can course correct if you need to, adjust those guidelines, right? If you're seeing, hey, my SMEs are interpreting this all differently or there's not agreement, you can kind of like adjust as you're going and get into that kind of iterative improvement flow. And we also have products here at Databricks that help with each part of this, right? So there's from model serving to just get your proof of concept running, ML flow for tracking inputs, the review app for actually like labeling, annotating, agent eval if you want to eventually do like more like monitoring, observability, like any of this. And then we also have a preview that I'll talk about briefly in a few slides to help with this entire flow and then also this like calibration component. And okay, quick takeaways. I always like to just kind of reframe like if you forget everything in this presentation, please remember the following few things. One, quality measurement is absolutely necessary for building and improving a GenAI system. Think about that vector, right? It's great if the magnitude keeps growing. Please just make sure the vector is pointed in the right direction. And quality measurement evaluations, the way to do this. If you're feeling stuck and you're not sure how to begin thinking about evaluations, refer to that 3x3, right? Where am I in the life cycle and what are my must-haves, must-not-haves, and actual usage patterns, right? Just like a super easy way to get started on this. You can avoid the Bermuda Triangle. I'm sure that like many of us have gotten stuck there for a while and gotten kind of frustrated, but there are principled approaches to measuring quality, and it is possible to find your way out of that into production. And the bottom line is if you start measuring systematically, you can start improving systematically. So real quickly, I'll just talk a little bit about our human eval private preview here at Databricks.
This is the only way to sign up for this. So if you want this, now's the time to grab that QR code.
So we basically have a workshop and a playbook where we dig even deeper into creating gold standard LLM judge evaluations. So this is everything from techniques for identifying target inputs, how to construct annotator guidelines, how to annotate data given one or more SMEs, strategies for improving agreement between multiple annotators, and what achievable calibration targets for LLM judges look like and how you might be able to get there. If you're interested, please complete our intake form. I would prefer if you completed the intake form, but if later the mood strikes you, you can also have your account team reach out. But this is the easiest and fastest way to get in touch with us.
I believe this link is not public anywhere but this slide, so fair warning. And this preview, just for the record, is manual and is being run by the folks you see on stage. So I can't promise that we will be able to provide it for everybody in this room, but our goal is to learn more about how to build products that will help our customers automatically build evals or kind of in a guided way build evals. And to do that, we want to work hands-on and just see where people are getting stuck, unstick them, and then build that into our products like the ones that were mentioned before. So
to close,
you get me back, and I'm going to editorialize for like 2 minutes, and then we'll take some questions. The first bit is a little bit of tough love for everybody here who looks at this and says, that's a lot of work. My answer is yeah. Do you want to have a GenAI application deployed that doesn't work? The beautiful thing about GenAI in all seriousness is, the applications kind of build themselves. With a few prompts, you can have yourself a really interesting, powerful GenAI application. It's pretty easy. In exchange, you have to put more work into the evaluation and the testing. That's kind of the interesting trade-off we have. It's different than coding, where kind of you spend a lot of time on the engineering and building the system, and then testing is kind of the last step of the process, the thing you do before you submit the PR, because if you don't do that, it'll get rejected. We're here to help, and I mean that across the board. This philosophy and the lessons that Pallavi just described are built into a bunch of the products that we announced yesterday. This whole approach pervades all the AI products that you will just use in the natural course of using Databricks. And we're constantly trying to find more folks, including several folks who are in this audience today who we've worked with previously, to just try to learn more about how to make our products better and continue to add new science and new approaches and kind of new ways of working around this. The other thing I like to say, I like to get philosophical at this point. I like to give a nice quote here. This is one of my favorite quotes on just kind of system building in general. It's from a long time ago. To put it quite bluntly, as long as there were no machines, programming was no problem at all. When we had a few weak computers, programming became a mild problem, and now we have gigantic computers, programming has become an equally gigantic problem. The increased power of the hardware made solutions feasible that the programmer had not dared to dream about a few years ago, and now a few years later, he had to dream about them, and even worse, he had to transform such dreams into reality because his CEO asked him to. Is it a wonder that we found ourselves in a software crisis? This is a quote from 1972 from Dijkstra about software because computers were getting more powerful and nobody knew how the hell to build big programs. There was actually, you can look up the Wikipedia article, this was described as the software crisis. Because, and you can just read this, the difficulty of writing useful and efficient computer programs in the required time. We didn't know how to do it. We didn't have principles of software engineering. The solution was basically the modern practice of software engineering emerged out of this crisis. Structured programming, object-oriented programming, modern testing, modern software engineering best practices, version control. All of that stuff came out of a crisis where the computers got really powerful. We tried to do big things with them, and we wrote software that kind of worked and then fell apart when we tried to change it. For those who know the famous Go To Considered Harmful article, that was something that came out around the same time. We had to learn how to build software properly, and that meant restricting what we did and being very disciplined about how we did it. And I think the same is true in AI. Some things are different this time. They're worse. I think the specifications for our agents are going to have to be behavioral. There is no equivalent to looking at the code. The thing that we always fall back on in software when people don't agree on what it's supposed to do is we look at the code, and the code tells us definitively what the system does. There is no equivalent in AI. Your prompt is not code. Your prompt is you and the LLM communicating through a few sentences or a few thousand sentences and hoping that you both happen to agree. But how do you check for agreement? You have to look at the behavior. You have to build an actual eval that looks at a behavior. I mentioned this before, but this is something I find so fascinating about AI. Reasonable people who are working very closely together can disagree about what an AI system does through the entire life cycle. You could go 6 months and deploy the system multiple times and still actually disagree with each other about what the system is supposed to do. The only way out of that is to look at actual behaviors and say, yes, we agree it's supposed to behave this way, or no, we disagree. It is at that moment when you try to build an eval or look at some real behaviors that you discover you disagree and have to go back and write a better specification. The only way to verify AI is through behavior. If you come to me and you say, well, we wrote this great prompt, I say to you, bullshit, you don't agree. I'm sorry, but you don't agree until you've actually looked at the behavior for the system. A prompt is just more vague words to try to explain whether you want the behaviors to be the same. Prompts are not code. If you tell me that, I'm going to tell you to go home and come back when you're ready to do some evals. Reliability is really the watchword at Databricks for AI these days. We want you to build agents that are reliable, maintainable, and will stand the test of time, really where we began this presentation. Our products are built to help you do that by design, and we're working hands-on with a lot of folks right now to understand how to build better products and make this easier for you. Again, great way to close. There's a QR code. Sign up. Again, signing up does not mean we'll necessarily actually get to work with you. Fair warning. You're looking at the workforce here. But we'd love to take a look and find some folks to work with, especially folks that will challenge our current products and break them in ways where we need to improve them. With that, thank you all so much. I think we have a couple minutes for questions.